In this lesson, I'll be showing you how to find the resultant of coplanar forces or vectors that are more than 2. I'll use this example to show you how we find the resultant of coplanar forces. So I'm going to be finding the resultant and in the direction for this problem. But before we go into that, I would like to take you through the steps. The steps are about 4. First, we resolve each vector or each force into perpendicular direction. We are going to find the x and the y component. We are going to resolve or do resolution of vectors. And step 2 is that we are going to add up the x components. The vectors in the x-axis or along the x-axis, we are going to add them up. Step 3, we add up the y component also. Step 4 is we are going to put the result together and combine it to have the resultant. So let's go right into the example problem. Here we have 4 forces. We have 12 Newton, we have 10 Newton, 9 Newton, and we have 15 Newton. So we want to find the resultant, and each of them are inclined at different angles with respect to the x-axis. The first thing I'll do here is I will make a table, make it a little more comfortable for me. So I'm going to make a table here now. The table is here, so I'm going to do that so that I'm going to have each of the components broken down as thus. So for this column, I'm going to put the force. For this column, I'll put the angle. Let me put it as theta. Then here I'll put this as the horizontal, or let me just say x component. Here I will put the y component. So I'm going to list out the forces in this column now. So the first I have is 10 Newton, 12 Newton, then 9 Newton, and 15. So the angles now, I'm going to put in the angles. 10 Newton force is inclined at 30 degrees to the horizontal. So I'm going to put 30 here. For the 12 Newton is inclined at an angle of 40 degrees to the horizontal. So 40. For the 9 Newton is 90 degrees. So even if we are not seeing any number here, is taken as 90 because it is perpendicular to the x-axis, to the frame of reference. So I'll put 90 here. Then for the last force, which is 15, that's obviously 60 to the x-axis. So what I'll do now is to resolve each of the 4 forces into their x and y components. And you remember that anytime we resolve forces, when the force is inclined at an angle to the x-axis, let's say 45, let's say we have a force is inclined at an angle of 45 degrees to the x-axis. When we resolve this force, for instance, we are going to have the x component to be 5 cos 45 degrees. The x component will take the cos of the angle, while the y-axis will take the sine of the angle. So that's what I'm going to do here now for each of the 4 forces. The 10 Newton force is 30 degrees to the horizontal, and when we resolve that, it's going to be a positive. It's going to go to the right this way. So that's positive 10 cos 30 degrees. That will give us positive 8.66. Then the y component will also be positive. It's going to go upwards this way. It's going to go upwards this way. So that's positive 10 sine 30 degrees, and that will give us positive 5. So for the 12 Newton force now, the x component will go in the negative direction. So it's going to go this way because the force is going towards this direction. So the x component will be negative 12 cos 40 degrees, which when we do that using our calculator will give us negative 9.2. Then the y component will go upwards this way. So that will be positive 12 sine 40 degrees. When we use our calculator on that will be positive 7.7. Alright, so I will continue now. I'm going to have 9 Newton now. The 9 Newton force is inclined at 90 degrees to the x axis. So and is positive. It's going to be positive. So I'm going to have positive 9 cos 90 degrees, and that will give us 0. The y component of the 9 Newton force will be in this direction. It will go just down like this. So and that's perfectly vertical. That will be negative 9 sine 90 degrees, and that will give us negative 9. Then the last force, which is 15 newtons, when we resolve that, is going to go this way. It's going to go towards the right, positive x axis. So that will be positive 15 cos 60 degrees, and that will give us cos 60 is half. That will give us positive 7.5. Then the y component, since it's pointing this way, the y component will go down this way. It will go down this way, and that will be negative. So we are going to have the y component to be negative 15 sine 60 degrees, and that will give us negative 12.9. So we are done resolving the forces, and the third step is to add up. We are going to add up each of these with their respective sign. So when we add up this, we use a calculator to add up this. We are going to have positive 7.1 as the sum of the x component. Then we are going to add this also. We use a calculator. Then we are going to have this to be negative 9.2. So we find the resultant next. That's the next step. The resultant r is given as the square root of the sum of the square of the x component and the y component. So we have r. R will be square root of 7.1 square. I put the sign plus negative 9.2 square. So when we use our calculator to get this, we get the resultant 11.6 Newton. 11.6 Newton. So it means the sum of all these forces combined together is 11.6 Newton. Having done that, we are now going to find the direction at which the resultant is going to go. So what I'll have you take note of is the sign convention. The sign convention is negative y goes down this way, positive y goes up, positive x goes this way, negative x goes this way, from a frame of reference, from a point. So I pick a point here now, and if I take the x component is positive, so from this point it's not going to go up, it's not going to go left, it's going to go to the right, because the x component is positive 7.1. so I'm going to draw or put a line that goes to the right this way. Now for the y component is negative, so that's not going to go up, that will go down. So from this same point I'll bring the line down. So this is the x component, the sum of the x component altogether, which is positive 7.1, and the y component is negative 9.2. Now I'm doing all of this so as to get the direction of the resultant. Now the resultant, we have already calculated it. The magnitude of the resultant is 11.6. so this is the resultant, and that's 11.6 Newton. Now to get the direction, I will get this angle, I'll call it alpha, then I'll work that on the next page. So to get the direction of the resultant, I'm going to find this angle, angle alpha here, and to get this angle I'm going to use my trigonometric ratio. So I find tan appropriate here because I'm looking for this angle. If I close this flank up like this, I'm going to have here to be negative 9.2, because this is parallel to this. And to find this angle is facing this, that makes this side the opposite, and here is the adjacent. Ratio, the acronym is SOHCAHTOA. We have sine, we have cos, we have tan, and since I'm looking for this angle which is opposite to negative 9.2 here, and I have the adjacent, tan is appropriate to get the angle. So that will be tan alpha equals to opposite over adjacent. So we have the opposite to be negative 9. I can put the negative aside now, because the negative is just telling us that it's going down, It's going down from the frame of reference, from the origin. Is going down this way. Okay, so divided by 7.1, that's the adjacent. So and that is tan alpha. Alpha, the angle, is gotten by the tan inverse of 9.2 divided by 7.1. I will have the alpha to be 52.3 degrees. So in essence, this angle now is 52.3 degrees. So what is the direction of the resultant? I'm going to one best way of putting the resultant is to put it in a compass bearing. So we have this direction to be north, we have here to be south, we have here to be east, and we have here to be west. So to get this now, everything in this quadrant must be 90 degrees. So if here is 52.3, from this point down is 52.3, I can do 90 minus 52.3, which will give 7 and 9. This will be 7 and 3. So this angle here is going to be 37.7 degrees. So the direction of the resultant. Now this is the resultant, and the resultant here is also have been gotten to be 11.6. So the direction now is south 37.7 degrees east. So that's the direction of the resultant, while the resultant itself is 11.6, as gotten down here, 11.6. So that's how we find the resultant of coplanar forces. Thank you for watching.